So now we're recording. All right. So Node.js. All right. So this is what we're going into now. So Node is a JavaScript runtime, and right here built on Chrome's V8 JavaScript engine. So it uses an event-driven, non-blocking I/O model, makes it lightweight and efficient. So. All right, so that's one of the big advantages with this. It's very efficient. Node, it can handle a lot of simultaneous requests. It's using that event model, that event loop that we looked at. It can also it's good for things like video games, or like where you have like these like lots of fast like interactions going back and forth between. You have two different clients that need to communicate, and they need to know where the other person is. In real time. And so Node can be good for things like that. It can be good for handling just lots of a huge volume of requests. When it comes down to like number crunching, it's probably not as fast as something like Python, but it's not made for that. So another major advantage, obviously, is that you can use JavaScript with it. And that's one of the main reasons why Node is catching on, is because you have all these JavaScript developers that can apply that same expertise to the back end. So, all right, so I've been throwing around this term back-end development, and we say full stack and front-end developer. So here's what those mean. So in an application, you have the browser, and this could be any client. This could be a mobile client, like an iPhone app. It could be a the website that's living in the browser, an Internet of Things device, any kind of client. And then this is where the HTML goes, the CSS, the JavaScript, all that stuff. This is where your React is, the Redux. All of that is on the browser. So the application server. This is where we don't have Java code, but this is where we're going to have Node and Express. So it's still JavaScript, but it's very different. They're two totally different environments. There's no browser, there's no like window object, there's no our events are different. They're not click events or things like that. It's requests that we're responding to that are coming in on ports. So just kind of in here how we set up event listeners on buttons, to detect click events or submit events on forms. Inside of our application server, we have ports that we listen on. So application, that term gets thrown around and used a lot in a lot of different contexts. You can refer to your server as an application. You can refer to your client-side browser as an application. You can refer to your mobile app as an application. So application can mean all of those things. So when we say like a server-side application, or depending on the context, you can tell what it means. But application can refer to anything in there. So so often what happens is when you go to a website like google.com, you send out a request, you receive back the HTML, CSS, JavaScript. The website gets built in your browser. You can then interact with it, and then as you click on things, it sends requests over the internet back to the server where this other code came from, and then it does some work and sends it back. So, it sends back a response. This is what we've been handling the front end of this, with Axios, with Redux Promise. That's what we've been doing. I've been giving you a pre-built application server that you've started up, but then now we're going to go in and teach you guys how to build your own application servers. So we're going to start out with the application server, how that works, and then we'll move into databases. So databases will be the next things that we get into, and how to structure the back end, and then how to do security and authentication and things like that, and how to save passwords, because you should never save a plain text password in a database. You always need to encrypt it, because if someone's able to get access to your database, they can, because your database is this permanent storage, on a hard drive, and so if somebody can get access to that database, that hard drive, they can get a lot of sensitive information if it's not encrypted when it's saved. Like the only place it's really safe is when it's like in memory, because then it's going to be, and even then, like we have to we use things like HTTPS, which encrypts the connection between the browser and the application server. So that's another thing too. So with HTTPS, and we'll go into this in more detail later, but that little S, secure, what that means is that when the browser and the application are talking, the contents that are sent back and forth are encrypted. And so that means that people listening in the middle that could be potentially intercepting your messages, they can't read them. And so that's what we have going on there. So we'll get into all of that theory and stuff, and that adds a lot of complexity, but fun stuff though. So all right, so when we say a full stack developer, that's someone who writes server code and then writes browser code. And so you're never really writing like database code, you're writing server code that interacts with the database. So the database is usually like you download it, get it up and running, and then your application server, you write code that interacts with it. And so all the backend code essentially for you guys will be just on this application server. All right, you guys have any questions about that?
Nope.
Okay. All right, so again, yeah, Node.js. So Chrome's V8 engine, it's a C++ application that, C++ is a little more low level than JavaScript, and it's it's code that reads your JavaScript code. And then there's code that reads the C++ code, and then there's code that reads that code, and all the way down until it's integrating with the hardware. But it's just different layers of abstraction. So V8 again, Google's C++ JavaScript runtime, and so what the runtime means is that you can have your code that you can start it up and have it running, and then it will stay up. The application will be up and running, and it won't be down. So because your JavaScript scripts that you've used beforehand in this scripting language, it just runs the script immediately. Whereas with the server, it's like kind of like you're writing these scripts, but they're going to stay open, and they're going to be listening, and they're going to be up and running, and they can interact over different ports. And so there's some different things that have been added to the language in Node that are not present in JavaScript in the browser. So we'll go over some of those in just a moment. All right, so Node, what you'll do is you guys should all have it because we've been using it for different projects and things like that. But so here's how we're going to create a server. So let's, oh yeah, and real quick, Ty, if you're wondering about the testing, the issue might be that you need to do, let me just show you this real, okay, so the issue is that if you're, when you're using React Router, you need to import this thing called memory router, and you need to wrap app inside of memory router. Yep, so memory router, and do that in the test file. And so that's probably what's causing some of your problems. And so this will provide the different dependencies that the app needs in order to run in the test. So this is just that basic renders without crashing test. And so you have to wrap app inside of memory router, which the irony is the test crashes, but then the application doesn't crash, because of the way it's structured. So that's a little curveball that React Router throws in there.
Okay.
So I'll paste this in Slack real quick. Okay. All right. So let's now. Directory, node, directory lecture. Oops. Okay, I'm going to go npm init. So npm init creates the package.json file. All right, and then now we're going to go touch server.js. Okay, and so we have our server.js file. This is going to be our main server file. And then we have to install one package. There's one package that we need right now. So we're going to go npm i --save, and we have express. So writing your server in plain Node, it's pretty verbose, and it's kind of messy, and so it's not ideal. But with Express, right here, so Express is it's a framework, and it makes it really easy to set up your like different routes, endpoints, things like that. So expressjs.com has some good resources. This Hello World is a good little just example for how to get it up and running. But all right, so yep, okay. So we're gonna go in and we're gonna write some Express code. So let's npmi-save express. All right, and then now we're going to go. We're gonna open this up in Atom. Okay. So we have our server file. Okay, so to use Express, we're gonna go const express is equal to require express. Okay, so this is the import of Node. So when we're in Node, we don't do imports express from express. That's an ES6 thing that only works on the client. Eventually, this will be supported in Node. It actually might be supported in some of the newer versions. So it might be, yeah, so it might be supported. But so the traditional way to do it is this const express, and then you go require express. And so same exact thing, like express looks for a node module. If I did /express, it would look for a file called express.js. It assumes it's a JavaScript file, so you don't have to put the file extension on it. Yeah, const express is equal to require express. This now gives us access to express. So now we're going to go const app is equal to express. So we invoke it. It's a function, and then it produces our application object. And so this app object has some different methods on it. And so we can go, one of them is we go app.get. And so we can call this get method, and we can pass it 2 arguments. The first argument is a route, so it's a string. And so this is kind of like on your React router, you have the paths that, like specified, like movies or movies / something like that. You'd specify paths. That's the same thing we're doing here in this string. This is like everything that comes after the localhost :5000. So this right here would be the base route. And then we have a callback function. And note, these do not loosely match. These have to be exact matches. So it's not like in React Router where it could hit, a request could hit multiple routes, multiple routes accidentally. This one won't do that. Okay, so then this callback function that we pass in, it has 2 different objects that come in on it. There's a request object and a response object. They're typically abbreviated to rec and then response. So they have a whole bunch of different properties on them, but the basics are res.send. That allows us to send a message to the browser. We'll go in and play around with those more in a little bit. I'm just going to go hello world. All right, so app.get, request, and then we pass in the callback function res.send hello world. Okay, so that defines a route. And then at the very end of the file, we need to specify, or we need to tell the app to listen. We need to tell it to keep running. Otherwise, this file will just set up all this stuff and then it will end. And so we're going to call app.listen, and that tells it to not close, and it's going to stay up. And then the first thing we do is we pass in a number, and this tells it which port to listen on. So we're going to say port 5000. This also takes in a callback function and allows us to like display a message to the console. So we'll say that server application listening on port 5000. Okay. All right. So we bring in Express, we initialize it, create our app, we set up a get route on it, and then now we're going app.listen to make the whole application listen. All right, so now let's come into here. And then what you're going to do is you're going to go npm i-g nodemon. And so nodemon, and you want to install it globally, but nodemon's pretty cool. It allows you to set up your server, and then it will automatically restart once you change a file. Just kind of like how when you did npm start and create React app, it would automatically restart whenever you saved a file. If we do nodemon server.js, then it will do the same thing. It will automatically restart when it detects changes. So, all right, server application listening on port 5000. This is that message that we logged out in here. So server application listening on port 5000. All right, so now let's go to localhost 5000, and we see hello world. Because the browser is launching a GET request. So there's another application I'm going to have you guys download, and it's called Postman. So Postman is a pretty cool application, and it allows you to mock up your HTTP requests so you can test out a server without having to have working browser code. So right here we can type in, we can go localhost 5000, and just like that, do a GET request, and we can hit send, and then we see our hello world came back in the response. So this is called Postman, so you'll be downloading Postman. And again, this will be all in your instructions for the project. So, all right, so you have hello world, getting returned right there. All right. Okay, any questions about this so far? Okay. All right, so inside of here, let's console.log request, the request object, so we can look at it. So let's, so you see here that the server restarted. So now if we go back to Postman, we'll send the request. We don't see the log in here. We have to go back to terminal. And then here's the request object. There's a whole bunch of stuff on it. It's really, really, really big. Like really big.
Sorry, I had a what are we looking at?
So this right here, this is the request object in that callback function from the server. And so it's this big object that has a bunch of stuff on it. Most of it, you're not going to touch, but there's some different properties and metadata things like, in here that you would use. When we start sending data like in post requests to the server, or when we start, doing some different things like that, then we will, then we'll be doing this, like, playing around more with it. So, all right. So that's the request object. Response object is pretty similar. Okay, so now what we're going to do is we're going to say app.get, and then we're going to call this name. All right, so what this right here, this is called a query parameter, or I'm sorry, a route parameter. So this is a route parameter. And so inside of here, what we can do is we can reference it by going rec.params.name. And so whatever they put right here, we can reference it using this, this value right here. So let's just go res.send. So essentially whatever they type in here, we're just going to send it back to them as a string. We're just going to show how we can reference it. Or we'll just say, actually, I'll make it a string. I'll make it a string. So let's do this. We'll say your name is So now if we come back into here, hello world. Well, right here, let's put the name Christine. So we send, and it comes back, and it says, your name is Christine. And then if we put hi, your name is Ty. So it's kind of like, it's like the client is invoking functions on the server. It's like you're defining these functions that are open to the world. And there's ways that we can restrict them and check to make sure that the person has kind of the right password, so to speak, when they try to access it. All right. So let's see. All right. So you have. All right. Okay. So yeah, questions about this at all throughout parameters?
Not from me.
Okay. All right. So the next thing that I want to talk about is console.log our rec.query. And so a query is when you put a question mark at the end of the path, and you can do this for any type of a path. But we're going to do a question mark, and then you can put some key value pairs. Message equals hello, like that. I'll send it. You still get the same response back. Let's go look inside of our terminal. And we see here on query, there's an object, and it gives us access to message, and then hello. And so we say back, your name is da 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 da. Your message was rec.query.message, like that. So if we came in and sent this again, it says your name is Ty, your message was hello. So these are the different ways that we can send information to the server for GET requests. And so often you'll have things where, like, you'll make requests like this, where it'll be like slash users slash, and then you'll have some like ID, which will be a user ID, and then that will be referenced on the server using something like this, like users slash colon ID, and it would be something like that, and it would get back a specific user. So that's a very common way to structure it. We'd have a route parameter like that. Queries are often, like you'd have something like search, like a search route, and then you have your query on it. And so, you know, this term, and then you'd have a search term, and that's how you would send search values to a server. So again, those are conventions because you could send them in many different ways, but these are, you know, yeah, common conventions that you see. Okay, so we've covered parameters, we've covered queries. Okay. All right, so now let's make a post request. And so up in here, I'll say, and then we'll call these users. And so what we'll do is we'll say add a request for users right here. Then we're going to go users.push. I'm sorry, this is a get. So we're just going to say res.send users, like that. And then we'll have an app.post. And this will be to new user. So we have our request and response. And then in here, what we'll do is we'll say there's a way to pass the information, the way that we reference the data that's being posted. So if you remember from Axios.post, you pass in two arguments. The first one is a URL. The second one is it's an object. And so, you know, it's, you were passing objects of data. So now here we're going to handle that object. And so we reference it by going request.body. So what we're going to do is we're going to go users.push request.body. Okay, users.push request.body. I'll add it into the users array, and then we'll go res dot. Now we can say end, and then we'll say user successfully added. All right. So let's come in here, and then let's go to users and send. It's an empty array. We haven't added anything to it. So now we're going to go to new user, and so this needs to be a post request. So we're going to change this to post, and then in our body, I'm just going to pick raw like this. I'm going to write out our object. This has to. I'm going to write this in JSON format. So name will be Ben. All right. And then right here, I'm going to specify the type. So I'm going to go JSON application./JSON. All right. So then now I'm going to go and send this, and then it says user successfully added. Okay. So now if we go back to our GET request for users, we can actually click over here. It'll save your different requests and all the stuff that you plugged in. So here's our GET request, and we send it. And oh, there's a null that was put in. So something that we have to do is, in order to process JSON data, we have to bring in another package, so another npm module. And so what we're going to do is this module is called body parser. So we're going to install body parser, and then now in here we go const body parser is equal to require body parser. Okay. So now after we create app, we're going to plug it in. So this is middleware. This is middleware, just like your, on the browser when we had Redux Promise. This is another middleware. This is a middleware on the server, and so our requests are going to feed through the middleware before they hit our different routes. And so we're going to go app.use. And we're going to go body parser.json. And so this tells it that it can parse JSON. So I'm going to save that. Let's go back in the Postman. And so let's, if we do this again, it'll be empty because the server just restarted. Let's go to new user. We'll send that again. This is user successfully added. And then now let's do our get. And then now we see that the object has been successfully added into the array. So with those requests, we were able to send some data up, and then we were able to retrieve it, pull it back down. So these are kind of this is the basics of APIs, backend. So when we say API, application programming interface, it's referring to this idea that we have these routes right here. And the client, through these routes, gets access to our application as it sends GET requests or POST requests and data to these specific routes. The application has code that will run in response and interact with the database and do different things. The client doesn't have to have any knowledge at all of how the backend does any of this. It just needs to know that if I make a POST request to this route and give it an object, that it will save the data. It doesn't need to know how it's done. It doesn't need to know if this is in Node or Express. It doesn't need to know if this is using Python or C# or Java. The client does not need to have any intrinsic knowledge or compatibility with what the backend looks like. Okay, so here's our basic server. All right, so there's one more thing that we're going to have to set up, and this one comes when you are retrieving an application that's being served on localhost 3000. So if we have a create React app and then we have that up and going, what happens is the browser, so I'm going to annotate this. So okay, I have a mouse plugged in. I'm going to do this. All right, so let me okay, so we have localhost 3000, and this is serving up our React application. And then we have localhost 5000, which is our Node application that's up and running. So here's our browser. So the browser, we go to localhost 3000, it sends a request to this port or that server. It happens to be on our machine, but if we're going to google.com, it's sending a request to google.com. And so then port 3000 is going to return back, the JS, HTML, and then the CSS. So that's all getting sent back down, and then that builds out our web page. And then here's a button. So now let's say that when we click on this button, it's going to make a request to our server. So our server, because it's being served from localhost 3000, the browser is going to make a request to localhost 5000. And so these are in two different locations. It's like two different names. This is kind of like saying this is like Facebook.com, and this right here is Google.com. So it's like they're two totally different domains in totally different places. And so when some code that comes from localhost 3000 and your browser tries to make a request to localhost 5000, 5000 is going to block it because 5000 is saying, hey, that code that's making the request did not come from me. So I'm not going to just allow them to access me. So they block that. And so, because the reason is maybe you have fake Facebook.com that you went to, and then they're going to try to access, the real Facebook with your login info, or your cookies and your session information and stuff like that. So that's why it's blocked. So what we have to do is we have to plug in a little thing on here for our development, that we're doing on the server that allows it to, safely, or it opens it up and allows it to handle requests that are coming from code that was served on a different port. Because just for right now, this is how we're going to structure it. Because in the future, what will happen generally is that you'll have a server up and running, the user makes a request to the server sends back the HTML and the CSS and the JavaScript, and then on subsequent routes or Axios requests, they will go back to the same server that it came from. So generally, most applications, you have your browser, and then you have your server, so we'll say foo.com. It'll make a request. It will receive back the, HTML, JS, CSS. So it'll get that back. And then as it works and does stuff, it'll send requests back to the same server saying, hey, here's a post request, create a new user. And they'll send back a response. And they're like, okay. And then you say, okay, now give me this, user information, and they'll send you back the information or some kind of response. So it's all between one server. So here locally, we have two different servers that we're interacting with. And so because of that, we have to enable it on our server here. We have on this localhost 5000 node server, we have to enable it to allow it to communicate with requests that are made from code that did not come from its same origin. So this was done as a security request. There's still ways to get around it, but yeah, so it's not a perfect security mechanism, but anyway, it exists. So, all right. So now what we'll do is actually let me clear that out. So inside of here, we have to install another package, and so it's called CORS, which stands for Cross-Origin Resource Sharing. So cross-origin, so like localhost 3000, localhost 5000, those are two different origins, and so it's sharing resources across origins. So here we're going to go const CORS is equal to require CORS. And then this is also a middleware, so we come out here and we go app.use CORS, just like that. And so now this opens up our server and makes it so when we try to make a request from localhost 3000, this is open. And so you should have some good example code of servers inside of your routing project. It's set up in this exact same way. It should have Express, body parser, and CORS on there. The same middleware is set up. It's handling GET requests and POST requests. Okay. So this is all of the information. All right. So in review, we covered, that Node is a JavaScript runtime. There's a V8 engine that it's built off of. The Google V8 engine that's used to run JavaScript inside of the Chrome browser. So the V8 engine was what's used in Chrome. So that's the that engine runs the Chrome that's what runs the JavaScript inside of the Chrome browser. It's written in C++. So we have this require thing that we use instead of import. We're using Express, which is a framework. Express makes it so we can create our routes very easily like this. Without Express, this takes a lot more code. So Express really simplifies this process, and you never see Node being used really without Express. If it's for a backend web server, or a RESTful API, you never really see Node used without Express. They're coupled at the hip. And then, all right, so we covered GET requests and POST requests. Now you've seen how to handle them. You've worked with GET requests and POST requests, but then now you're seeing how to handle them on the server. We have our middleware that we're putting in here. That's just like middleware on the client, where it was in between the action creators and the reducers. Here, the middleware is the requests will feed through these before they reach the routes. We covered app.use. This is where you pass in the middleware. We covered listen, so you have app.listen. So we create the app with Express, their application, and then we have app.use, app.get, app.post, app.listen. There's more. There's many more methods, but these are the core ones. These are all the ones you need to know right now. We covered the request and the response objects. They have different methods on them. So like, rec, common ones. You have a rec.body, rec.params, rec.query, and then generally on res, you're just going res.send. Send information back. Okay. Again, so params, on a route. So that would be params, the parameters, and then. But if we did this, this is a query parameter. Okay.
So, sorry, I'll hold this till the end, actually, of the lecture.
Yeah, it's that's actually the end of it. That was me. I just got to the bottom of my list for the things that we've covered.
Cool. Can you go over how you did npm init without having to fill out all the things?
Yeah, you just hit enter. Yeah, you just press enter and just skip through it all. So like here I have an empty directory. I just go npm init, and then I just hit enter and skip through it all. That creates,
Gotcha.
Yeah, that creates my package.json file. And so that's what I then, so you need to have that up before you start running npm install. Otherwise you're not going to be saving your stuff. Actually, yeah, okay, so if I do npm i-save express, actually maybe it's going to create a package.json file. Nope, yeah, so if you do --save, nothing happens, nothing is saved. So it installs the module, but it does not save it to a package.json file.
Okay.
And the reason that's important is because usually you're not going to save your Node modules on GitHub because it's a huge folder, and so of stuff you're not even touching. So usually you just have your package.json, which is like the recipe, and so you'll commit that, send it up, and then if you're on a different computer, you clone that down, and then you just run npm install, and then npm goes out and gets all the dependencies that you need that are specified inside of package.json. So that's why we do it that way. It speeds up the the pushing and the pulling times, the cloning, and yeah, it's a better workflow.
Okay, so this didn't automatically create the node modules folder, right? So
Yep.
if you did npmi,
Yeah, it didn't. So now it's empty again. So if I do npm init, this just creates the package.json file. So you see here package.json. As soon as I install something, that creates the node modules folder. So you do not have to manually create a node modules folder.
Gotcha. Okay.
Okay.
And what did you want us to globally install again?
Oh yeah, nodemon. And then here's our packages. You'll go npmi --save, and then it's going to be express, body, parser, and cores. All right. So those are the different, those are all the different pieces that you guys need to make this work. So again, nodemon, it makes it so the server automatically refreshes when you save it. Otherwise, so you see here how it restarted and it logged out the message over and over and over again. If I just did node server.js, which is what you guys have been doing, then you have to restart the server if you make any changes to the file. And so if you're in there editing the file, you have to make sure to manually restart the server. So nodemon makes it so you don't have to do that.
All right, and then to invoke it, what do you type? Nodemon server.js?
Yep. Yeah, nodemon server.js. Yep. Yep. So real quick thing with Node. Node is just the ability to run script files from the command line. So if I go touch script.js, and then let me open this up. So in script.js, if I just said console.log hello world, like that, and that's all that's in there, I can go node and then script.js, and then it runs, and we see hello world. I could have const foo is equal to a function like this that takes in x and it returns x times x, and then I can go console.log foo, and then I can go 25, and then we go node script.js, see 625 printing out. So it's a pretty, so like when you guys are doing your coding challenges in the morning, you can actually just do them right in here if you do node to run it. You could just write them and run them straight from the command line without having to do all the other stuff. So yeah, it just allows you to run JavaScript from the command line.
Sorry, I spoke out that last little thing. What did you say?
So yeah, it's just you can just write a JavaScript file, and you just have a JavaScript file, and then you can just run it using Node. And so Node just means that you can run JavaScript files from the command line. And so, but then also we can specify some things to have it listen and act as a server. That's what Express is helping us do that. But Node really is just allowing you to run. We're running JavaScript outside of the browser, because before JavaScript would only run in the browser. But right here, we're not in the browser. I'm just running it on the computer. So Node is a C++ application that lets us run JavaScript code inside of the command line, from the command line.
So anything you install with npm runs on Node, right?
Yeah, that's all with Node, yep. Every npm module you bring in, that's all JavaScript too. They're all 100% written in JavaScript. Okay. All right.
Yeah, those are all my questions at this point.
Okay, Christine, do you have any other questions?
I don't think so.
Okay.
Did you talk about what the project is?
Yeah, so with the project, you guys are going to be building a server up just from the ground up. You're going to use Postman to test the different routes, and then just gonna build out a server. And then next time we're going to take this little const users thing, and instead of doing that, we're actually going to have you guys saving stuff to a database.
Sounds fun.
Yeah, so that's when it starts getting pretty fun, when we start bringing in different kinds of databases, and yeah, it's fun stuff. All right. Okay, so if there's no questions, we'll just end, and then I'll have your homework ready by the end of dinner. So I need to go in and update it a little bit based off of some of the stuff I covered. I covered a little more in our lecture than I was planning on.
That's always a nice thing.
Yeah, so I was going to save some of this for the database part, but this is a pretty good point to get to. This covers a lot of the fundamentals. With everything that we've covered now, you guys could duplicate all of the servers that I've created for the projects that you've been using. So you should be able to go in and read and understand all of those servers now. There shouldn't be anything in there that we haven't covered.
You know what's cool that I can do now? I can actually listen to like those like YouTube videos when people talk about stuff and understand them, because I couldn't before. So it was useless.
Yeah.
So I can learn them in the background while I'm like doing like other chores, and I can pick up stuff.
Yeah.
Before it was just gibberish.
All right. Well, fun stuff. Yeah, and I'll let's see. Ty, do you have any questions about your project?
No, CSS is just harder than I remember.
Yeah, it's kind of a pain.
I hate CSS.
Yeah,
but I haven't used it yet.
Yeah, I want to try to. Yeah, in the future, I want to have a really good CSS master come in and do some stuff with you guys, but anyway.
All the cascading and stuff, I've tried to figure that out, but even when I'm looking at like the inspector and I'm not then there's things crossed out, and I don't know, like, yeah. Anyways,
yeah,
I get that in theory, and then I look at it in reality, and I'm like, why is that happening? And then there's like a million. Everyone has a million CSS files now. So you look inside like a website, and you're trying to figure out what's going on, but there's so many different pieces now, right?
Yeah. Well, you
I used to look at a website and had 3 CSS files. That was it.
Yeah. So the cool thing about the inspector is we can come in here and then let's do inspect, and we can modify a lot of these styles. So if you go element.style at the very top, this is like it trumps everything else. Let's see, let me go back on color. Oh, let's see, why is that? Maybe, okay, let's do it on the body. So right here they have it as white. And so we could actually, let's say we wanted to change it to this red color right here. And, oh, it's still not changing. All right. Yeah, so sometimes you have to like go in and like try to figure out.
That's what I'm saying. There's so many different pieces that do different things now. Like there might be like, I don't know, all sorts of things that are operated by functions and stuff now, right? Like you can't just go into and change it because.
Yeah, it makes it tricky. Oh, I think there might be an overlay. I wonder. Okay.
Oh, scroll down. Scroll down.
There we go. Oh.
No, on the page. If you change that back to white and you scroll down, it changed something else to red.
Oh, okay. All right. So let's make the whole page the color of this guy's lips. All right. This guy's nostrils. All right. So you can kind of do this interesting little color picker thing, which can allow you to get specific colors. So if you're like, ooh, I want, I want the Twitter blue, and I want to find out what the exact shade is for that. You just find somewhere where there's a color on it, and then you can go and hover over it, grab it, and you can see, okay, so 339DC3, that's the hex code. I can grab the blue in there. So you can kind of tweak things a little bit. When you're working on your own application, this can help you to kind of get things right. To test responsiveness, something you can do is kind of zoom in and out and see if it all explodes and dies. Stuff that's crossed out.
It's a style sheet where another style sheet is taking over for that, or it's the logo one.
Yeah, there's a more specific CSS selector that's overriding it. So if we find something that has a lot of stuff on it, so like on the body, so here we see, oh weird, that's the background, but well, there's not even a lot of stuff on that. This one's really big. Okay, here we go. So all the stuff that's crossed out, it's because this has some styles applied to it because maybe they in their style sheet they just have a generic thing they're applying to all input fields, but then they have some classes that are overriding it, and then maybe for this one specific infield they have an ID. Maybe they have an ID that overwrites some of that stuff as well. So I have no idea what this is doing. Huh. Oh, okay. So we have transition. All right. So yeah, that's anyway some of the basics for how this all works. The computed tab shows you like for the element that you selected, it gives you all of the box model specifications. So it gives you the it's actual the content size, the padding size, the border width, margin. Yeah. So there's a lot of different tools in here, and you can just you can toggle stuff too. You can just unclick things, and you can see how this all kind of melts together and looks ugly now. But and again, if you refresh it, any changes that you put in here are gone. So yeah, CSS. Cool. All right, well, I will touch bases with you guys a little bit later, and then I will get everything posted up for you. I'll also get this video uploading right now.